Hello again, you sick, twisted weather freaks, and Happy New Year, everybody. This is meteorologist DT from WXRisk.com, the command of chaos, kernel of confusion, captain catastrophe. It's time to talk about this week in weather, and a lot to talk about. First, let me apologize. I wanted to put this video up about 10 hours ago, but I got a sick spouse here at home. I had to take care of her, and I'm not feeling that great either. So, I'm going to avoid doing that coughing thing. I know it irritates some people when I cough in the microphone, try and clear my throat. In fact, right now I'm actually sucking on the cough drops to keep the throat from going crazy. So let's get right to this and see how I can get through here. This is going to be a lot of information here, explaining to you what's going on and why. Obviously, there are a lot of questions here. We'll talk about the sudden stratospheric warming and the polar vortex again. There's no threat of any winter weather before the middle of January 2019. And of course, there's also a lot of concern that the winter is over, that the whole forecast is a bust, including that would be mine. And while I suppose that is on the table, I'm not ready to go that far yet. And I will explain why. So let's get talking about this and see what's going on here. So we'll start up first by going over something I showed last week. Now, this is an example of how the polar vortex can be oriented. The image on the left is when you have a big solid polar vortex, one big blob here. See this? This is the heart of the polar vortex right there. It's one big piece. The image on the right is when it splits up into several pieces. There's a piece of the polar vortex, there's a piece here, there's a piece here, and so on and so forth. So in terms of what this means, this is when you have the Arctic oscillation, essentially when it's positive. And over here is when you have the Arctic oscillation negative. So that's what we're looking at basically. So now let's take a look what happens when you have the irregular polar vortex. There's no warming, just one big blob sitting up there. In other words, you're looking at the image on the left here. So what happens here is that typically the Arctic oscillation remains positive. And you can see it's situated quite clearly here. You can see there it is right in this area here. So we can see what happens is, and because it's positive, it's over the North Pole, you end up getting a very strong jet stream going like right across the country this way. And everything north of it is very cold, and everything south of it is quite mild. And indeed, that's what it looks like here. You can see this is a little more clarity here. This is when you have your polar vortex as one big feature, and the Arctic oscillation is positive over the North Pole. And this is what happens. All the cold air gets stuck over Canada, and the U.S. sees fairly mild conditions for the middle of winter. In addition, the Eastern Pacific Oscillation is usually a positive as well. And what this means is that we have a low over Alaska and the Gulf of Alaska, which floods the Canada, the icebox, with mild Pacific air. We have a very strong Pacific. This is the feature here, and we end up having a very strong, very strong Pacific jet coming in, and as a result, the Eastern Pacific Oscillation here ends up going positive, and we end up getting mild air into Canada. So all the cold air gets stuck up into here. In other words, we don't get these big ridges coming out of Siberia bringing the cold air in. That doesn't happen when the Eastern Pacific Oscillation is positive. Okay, so that's one of the things that happens when you have sudden stratospheric warming. Those things change. Here's another. This is the NAO, and in this issue, and in this example here, the NAO. Let me move this over a little bit. Is centered over is positive as well. Here the NAO is positive, okay, and we have a big a vortex over an upper low over Greenland, and what happens is, of course, you end up getting not a lot of cold air coming southward. It does this, and all the cold air is wrapped up around Greenland and northeastern Canada. So that's what happens typically when you have the polar vortex in one big piece. In other words, again, this image on the left. Now, what happens when the polar vortex splits? Then you get this feature. And again, we have several little what we call baby vortexes. One here, one here, one here, and one here. And this is when the Arctic oscillation goes negative. And this allows you have a lot more phasing between the jet streams. The Arctic jet can come southward, it can meet with the subtropical jet, and that's how you get your winter storms. Remember, you need moisture and cold air to get your winter storms, not just cold air. So what happens is typically when you have the polar vortex split or the Arctic oscillation goes negative, well, this is what it does is it forces it here. You can see what happens. You have pieces of vortexes all over the place. You have one here, you have another one here over eastern Russia, another one here, and so on and so forth. And then you've got the cold air coming southward, mixing with the mild air over the Gulf Coast. You're not getting all sorts of moisture, especially when you have a weak or moderate El Nino, and you get storminess. And the this here is the Eastern Pacific Oscillation. In this case, what happens is because the vortex is split, you get a lot more. The Aleutian low, the Alaska low goes back to the Aleutian Islands. So you go, instead of being here, it goes back to here, and this allows the ridge to develop much stronger over Canada, and you get your ice box out of Canada, the cold air coming southward. And then you also typically get your P&A pattern, which is connected also to the EPO. So when the EPO goes negative, it gets the cold air comes southward, and so on and so forth. And then here is also the NAO. What happens here is that instead of the big upper low over Greenland, you have a big ridge, and that forces the cold air to come south into Europe and into the central and eastern United States because of this right here. This is a ridge, not a vortex. So all those things happen when the vortex splits. Now, the problem is that we've been talking about this for a while. Now, this is from Judo Cohen, Dr. Judo Cohen over at AER, and he posted this on his Twitter page and his web page. This is from December 23rd. It showed the polar vortex splitting. You can, and I highlighted this before, so you can clearly see that. Oops, there you go. And now we've been talking about this for a while. Now this is one from January 1st, 2 days ago, and here you can actually see it has split. As of January 1st, it finally did split. This is not a projection. This is actually this is just January 7th. You'll see that the data shows it did actually split on January 1st, January 2nd. And you can see Judo Cohen thinks it's going to split into three pieces, which would be really phenomenal if that were to happen. And we can even see here, this is the European model from way back on December 22nd, and it also showed the vortex splitting. So we've been talking about this for a long time. Now, the problem is that we have to wait for it actually to occur. So even though we've been talking about it since almost the middle of December, then we have to wait for the event to actually occur. Then we have to see the pattern develop. It takes 10, 12, 14 days for the polar vortex split to begin to affect the overall pattern. So if it doesn't occur until January 2nd or January 3rd, 10 days is January 12th, 15 days is January 17th, and so on and so forth. Now, this is a projection of the computer models showing how the polar vortex is going to shift. And what we're looking at here is a change in the wind direction and the change in the temperature. So this right here is wind. Okay, so above the zero line right here, this is west wind, and then here is the east wind. So when typically, remember, the winds go west to east. So when in this case here, when it goes below the zero line, let me change my marker so you can see this a little bit. When it goes below the zero line here, that means the winds have changed now to an easterly direction, and which means that the vortex is splitting. Okay, and here is the same thing with the temperature. You can see the temperature rise here. You can see a huge rise in temperatures, and this area here is showing the warming in the Arctic region. So, but remember now, this data right here is, look at the time here. This is December 22nd. So even the projection had it occurring around the 26th of December. See this? Or the 26th of December. But that's not what happened. It's only just occurring now. Not December 26th, January 2nd. So this is one of the reasons why the turn towards a colder pattern has been delayed. If you're complaining that it's getting pushed back, it's getting pushed back, it's getting delayed, you're right, it is. But there's a reason for that. Okay. It now actually has occurred. Finally, you can see this. And we can clearly see again that the winds have now turned easterly here. You can see that. And of course, and there are westerly winds here. You can see that, and the warming is still there. Very strong warming. And then there's a little bubble, second rise here, and then drops down, back down again. So the vortex split is underway. That's the good news. Now, before we get to that, however, again, this is going to take, let me change my mark here so we can see it better, 10 to 14 days to impact the pattern. So until that happens, we've been stuck with this. This is the MJO, and I showed this last week. This is as of December 25th, 26th, Christmas Day. You see how it does this little dipsy doodle right in here? This little, it goes like this and it goes back and forth like this. Okay, that's a stall in phase five. Now, before then, it was moving at a very good pace and it stalled there. And as Dr. Michael Ventris showed from WSI, that does happen from time to time in December. There seems to be something about phase five where the MJO stalls in the winter months, or especially in December in phase five. It's not that unusual, but it is important because what it means is this. This is phase four, phase five, and phase six. Now, I've shown this before, so let me shrink this so you can see it a little bit. Make sure you can see it a little more clarity here. There you go. And now you can see, look how warm it is, phase five and phase six. So again, we're in this. And because we had this little dipsy doodle thing right here, that stalled it, delayed it. So yes, this was another delay. As a result, last week or 2 weeks ago when I showed this, it looked like it was going to get cold January 5th, and you can see this, January 6th. Okay, this turned out to be, because of the delay, bullshit. This is wrong. Completely wrong. No doubt about it. Completely wrong. Because of that delay in the phase five. So there you go. And of course, we didn't see not seeing that cold there. Now, as we go forward, here we go. Now, this is the projection for, let's see here. This is for taking us. This was okay. The image on the left. Excuse me. You couldn't see the print here. This was the actual polar vortex as of December 28th. And you can see we had one big center here. Here's the ridge, and there's the vortex. Okay, so here's the high. Now over here, this is January 3rd. You can see the split. There's your high. There's one low here. There's the other low there. It has split. See that? It's definitely split. So, like I said, we are on. It is finally underway. And then you can see that if we go out, this is January 8th. The splitting continues, and then of course there's a speculation that it's going by January 15th that it's going to split into three different sections, which would be really significant and really showing a powerful second half of the winter coming. Possibly. Now that with the SSW, that is to say the sudden stratospheric warming event has actually occurred, now that the vortex is splitting, remember, it does not guarantee anything. Okay? Sudden stratospheric warming events can and do impact Europe and Asia, Eurasia, not just North America. Okay, we're used to thinking they happen only in the impact mainly in North America because we live here and we want it to happen here. But there have been several studies over the last 20 years where some of the main impact has been over Eurasia, not in North America. And also keep in mind it can take 10 to 14 days before the direct impacts of the sudden stratospheric warming actually shows up and affects the pattern. Now let's take a look at Europe for a second. These are the temperatures of the last 7 days, and you can see it's been pretty warm in Europe, except for a little below normal in Russia and the Ukraine, but for Europe it's been pretty mild. What happens is it looks like that the first impact of the cold is going to be felt in Europe first, not in the US. And this is something you have to keep in mind here. Now, this is the actual pattern as of January 3rd. And you can see a huge ridge here over the UK and a massive trough over Central and Eastern Europe. So what happens is this continues here. Goes a little further to the northwest towards Iceland, and this trough is pretty deep, and we're getting some cold air coming in here. So that's a fairly cold pattern. And then if we go beyond that, this is the 6 to 10 day, 11 to 15 day. We can see the deep trough over all of Europe, Eastern Europe pushing into Western Europe, and temperatures are clearly running below normal. And you can see that here with the 6 to 10 day, the next 5 days and the 6 to 10 day temperatures running below normal. So it may be that the sudden stratospheric warming, the polar vortex split, is impacting Europe first. Another problem we have, and this is a big problem, is the Pacific jet. It is howling. A lot of meteorologists have been talking about this. My friend Anthony Marcel has been talking about it. And this is a real problem. Now, until this Pacific jet begins to weaken, we're not going to see much to change. Now, in some ways, this howling Pacific jet is connected to, the MGO being in phase 4, 5, and 6. They are connected in some ways. But this is the actual one as of January 3rd, January 4th. And in case you don't know how to read this, let me go over this. You see this white stuff right in here? That's 180 knot winds, 200 knots. That's really howling. This is the top of the atmosphere, 250 millibars, way up there, 30,000 feet up there. And you can see a surge here, the howling Pacific jet. And then it continues. The top image here is 84 hours, and the bottom one is 180 hours, taking us to January 11th. And you can see this stuff is just howling. So in order for the pattern change to occur, we have to get the Pacific jet has to drop. We just absolutely have to. This is a vital. Okay, we have to get this pattern to change. We cannot have this howling Pacific jet. What this is doing is this energy is slamming all the way into the west coast and producing a persistent trough on the west coast and a ridge in the eastern United States. So we've got to get this to change and buckle. Now, what's going to cause it to change? Well, maybe this. Again, Anthony Masello shows very nicely on his Twitter page that we have a huge area of high pressure in Canada, over China and Korea and Japan, which is helping to produce really strong winds. And if we can get the angular momentum to change and so on and so forth, a lot of things have to change here. We're watching it. If the Pacific jet breaks down, we'll be off to the races. But you have to get that Pacific jet to break down. This is just a real problem here. This is not a good sign. So I am worried about this. Really, I am quite a bit. Now, if we look at our teleconnections here, and again, these are from Weather Bell. You see the Arctic Oscillation. You want to look at the green, which is the mean color here. You can see it generally goes negative throughout into the middle of January. This here is the North American NAO here. And this, as you can see, it's negative. Then it's neutral and it's kind of negative again. So that's not too bad. On the Pacific side of things, this is the Eastern Pacific Oscillation. As you can see, it's strongly positive here. That's not good. But eventually it does turn negative here in the middle of the month, January 10th, 11th, and then it starts negative here. And then the PNAs also looks pretty flat as well. So not great, not horrible. Now, as we can see, this is the current MJO, and we can see where it is very nicely. It is now in phase 6, moving towards phase 7. You can see it. Let me highlight so you can see it right there. All right. And that has significant implications. Now, if we look at the projections, the models, here's the Japanese model in the upper left, right here, Japanese model. This here is the Australian model, and this here is the European model. Notice that the Australians go further out in time, but what's happening is they all bring it into phase 7, phase 8, then kind of into neutral zone a little bit. Here's the European 7, phase 8 by, let's say, January 10th or 12th. And then back in neutral zone a little bit. And then the Australians do this little loop-de-loop here, and it may come back out again. So they all take into phase 7 and phase 8, which are better cycles for everybody. And the extended MJO, this is one from Kyle McRitchie. He runs the off the CFS, and these are different CFS ensembles. And you can see, again, notice that it gets into phase 8 around January 13th. Through the 18th, and then look, it goes in a neutral circle, but then it looks like it wants to come back out again in phase 8 and 1 for February. This would be great for winter if we could get into phase 8, 1, and 2 in February and March. That would be terrific. Now, what does that actually mean, phase 8? What does it mean for the pattern? Well, this is phase 7, and as you can see here, during the month of January, when we have an El Nino, so this is also January, phase 7 with El Nino. Okay? And we have a big ridge here in the western Canada, a bit of a ridge here in eastern Greenland and the Arctic region. A nice trough here, low pressure coming into California, and then another area of low pressure off the mid-Atlantic. So this implies low pressure areas tracking in an east-northeast direction, a somewhat colder pattern. Not horrible, not fabulous, not horrible. And then this is phase 8. Again, a deep trough over Texas. This actually favors more the Midwest than the East Coast. But phase 1, which I don't have here, it actually goes back to the East Coast again. Now, the CFS weekly, the CFS daily ensembles, also you can get this from Colin McRitchie. They do show the pattern change coming around January 20th. You can see the deep trough over the eastern U.S. Right in here. And then this is January 25th. And then if we go beyond that, this is January 29th. Pretty deep trough over the eastern U.S. Looks fairly cold. So, possibilities. So my summary is that the window here is January 15, March 15th. That's our 60-day time frame. If by January 15th to 20th there are not clear signs on most of the models that a significant pattern change is coming. If that Pacific jet is still howling, then it may be time to give up on the winter, at least the winter being a bad one. So, there's our time frame. We're watching it carefully. All right, now the European weeklies are doing their thing. They're pretty mild through January 15th to 20th. You can clearly see that. Looks pretty mild here with the temperatures. And you can see not much ridge on the west coast here. There's your polar vortex here. No blocking over here. It's just a word blob pattern. But after that, starting the last week of January, it goes bonkers. And you can see it turns much colder, with a huge amount of, excuse me, blocking in Arctic Oscillation, NAO, big ridge at EPO right here. Much colder pattern, you can see it. So there is some indication. Now, the European Weekly's been showing this now for 2 weeks. Okay, this is, we're showing this now for the last 3 runs since last Friday. It comes out Thursday night, Friday morning, and then again Monday night, Tuesday morning, and then Thursday, Friday. So last 3 runs has been showing this significant change in the second half of January. Let's see if this is correct. I hope it is. One final note here I want to point out to people. Now, you may remember this historic snowstorm, December 19th and 20th. It certainly was a very big snowstorm forecast for weather risk, since we, again, out forecasted most people with this snowstorm, especially NWS and the TV stations in Richmond, Roanoke, Charlottesville, D.C., say, etc. But the point here is that this storm is December 19th to 20th. It was a big snowstorm. Now, later on that winter, remember we had the big snowstorm on January 30th in northern North Carolina and Virginia and southern Maryland. Then we had the huge snowstorms in February in central and northern Virginia, into Maryland and Delaware and Pennsylvania, New Jersey in February, the back-to-back, almost back-to-back blizzards. But the point here is that that was a great winter. We all know that was a great, great winter. But the time between January 30th, okay, and January 29th, and this storm here, that's 40 days. And if you look at the pattern from 40 days, it looked like shit. Okay, this is here the upper air map for December 23rd, 2009. Okay, big right here, trough on the west coast. All right, all this specific energy coming in. Look, this map here is December 25. Huge low in the plain states, warm and rainy on the east coast. That's December 25. And then even going to January, the pattern broke down. Look at this howling Pacific jet coming in this way. No ridge on the west coast, all mild air, all the cold air is way, way up here in Canada. This is a rainstorm, this low here. And then look at this pattern here, January 22nd. Monster trough on the west coast. Are you kidding me? Look at the size of this thing. This is all Pacific energy here. No cold air anywhere in the North America on this thing. So, we have a long way to go yet before you give up on the situation. And then even look at this map. This was January 25. This is 4 days before a major snowstorm hit Virginia, Maryland, North Carolina on January 29, 30th, 2010. And look at this. Huge snowstorm blizzard in the Midwest, 50s and 60s up and down the East Coast with rain. So, okay, my point is polar vortex is split. We'll see what happens. It's going to affect Europe first. Takes 10 to 14 days. Try not to freak out before then. We'll see what happens by the middle of January. It's too early to give up on the winter completely. The winter 2009, 2010 is a classic example of that. So let's see how it plays out. It's not overdone yet. The data looks like it's going to flip. It really does. But we have to get that Pacific jet to break. That's a big deal. This is meteorologist DT from weatherist.com. I'll see you on the Twitter page and on the Facebook page.